Alright kids, in this video we're going to talk about reasoning and problem solving with rational numbers. Okay? So we're going to talk about how you can use rational numbers and think of them more than just as numbers on a number line. Alright? So let's take a look at our first situation. Sam and Nate are riding the elevator in their building. They rode up 10 floors, down 16 floors, and up 25. If the elevator ended up on the 36th floor, on which floor did they start? Now, if you're like most people, you're thinking, okay, what floor did they start on? Well, it could be any floor, okay, that they started on. But what we do know is this. They went up, which is a positive number. They went down, which would be a negative number. And then they went up, which would be positive, and they ended on the 36th floor. So we know that somehow they ended up on the 36th floor. What we don't know is where they started from. Okay? So whatever they did, their pattern was this. It was first up, so they rode up first, then they rode down, and then they rode up. And when they ended on that last up, they were on the 36th floor. So that's our situation. Alright? Now, if you're going to do some problem solving and reasoning, you want to ask yourself, what do you know? Okay? Well, we know, like we just discussed, that they went up 10. 10's a positive up. They went down 16, and then they went up 25, and ended on the 36th floor. Can you kind of picture this on a number line? And because it's a building and an elevator, you could picture your number line going up and down. Then you should ask yourself, after you ask yourself what you do know, ask yourself, what are you being asked to find? Well, you're being asked to find on which floor did they start riding the elevator. Okay, so this is all information that we do know. Okay, we do know they went up, which is positive. We do know they went down, which is negative. We do know they went up, and we do know they ended on that floor right there. So one of the things that's nice to do is to make a diagram of this. Okay? Now, if you know the ending position and each change made, then you can use the inverse of each change to work backward. Okay? So, what we don't know is the starting floor. Okay? We don't know that. Okay? But what we do know is they went up from that floor to this floor 10 floors. So we know the first change was 10, which put them to this unknown floor. But then once they reached that floor, they giggled, laughed, and they decided to go down. And they went down 16 floors. And then once they reached this unknown floor, they giggled and laughed, hit the button again, and they went up 25 floors. Okay? So our pattern is positive 10, negative 16, positive 25, ending on the 36th floor. Now, if we want to use the inverse, all we have to do is say, okay, well, let's get on the 36th floor, and instead of going up 25, let's go down 25. So from here to there, we're going to go down 25. So if we take 36 minus 25, we get 11. Okay? So now we know that they were on the 11th floor. Okay? Now, in order to get to the 11th floor, they actually came down to it. But we're going to use the inverse. So instead of going down to get to the next floor, we're going to go up. So we're going to use a positive 16. So we're reversing, and instead of going down, we're going to go up. So we would then take 11 plus 16, because from here we went down 36, we went down, so that would be 36 minus 25, and we would get 11. So over here we're going to do 11, and we're going to add 16 to it, and it will take us to 27. So now we're on the 27th floor. Now, in order to get to this 27th floor, they came up from the starting floor. So in order to go back down to the starting floor, we're going to get a negative 10. So now we have 27 minus 10, which equals 17. So we are correct when we say that the 17th floor is where they started. And if we were to actually check our math, we could do 17 plus 10 is 27. 27 minus 16 is 11. 11 plus 25 is 36. So we could actually see, if we come up with these numbers, we could actually plug them back into what they did and actually see how it works. All right? Well, why don't you, here's a situation for you to work on. Allie, and she's doing a little bit of savings, okay? Try this one on your own. Go ahead and pause the video and see if you can figure out the answer to this question. Okay, here we go. Hopefully you got the right answer. Okay, the situation is this. Allie is saving for new computer equipment. That costs $110. She started saving in week 1. She saved $26 in week 2, spent $14 in week 3, and saved $47 in week 4. She now has $91. How much did she save during week 1? All right, so let's take a look at this and see how you could have solved it. Now, there are several different ways you could have approached this or reasoned it out. Okay, I just happen to like doing it like we did the elevator problem. Okay, one of the things that we know for sure, okay, is that Allie is saving for new equipment that's going to cost $110. Really, this isn't relevant to the problem. We really don't need to have this amount in order to figure out what week 1 is, because she only has $91 at this point. Okay, so we can start thinking in terms of positive and negative. Okay, she started saving in week 1. Okay, so in week 1 is where she began to save her money, and she saved $26. So in week 1, she saved $26, which was a positive, okay, amount. And then in week 2, okay, in week 2, she spent some money, okay? So she saved $26 in week 2. She saved $26. And then she spent in week 3, she spent $14. Okay, so that would be a negative. And then in week 4, she got back into the savings in week 4, and she saved $47. Okay, so her pattern is in week 2, she saved $26. In week 3, she spent $14. In week 4, she saved $47. And by the time it was done, on week 4, she had $91. But what we don't know is what went on in week 1. Okay? Now, obviously, from week 1 to week 2, she did some savings, okay? Something happened there where she went up, all right? So now what we're going to do is going to use the inverse operation. So let's take our 91, and instead of saving $47, we're going to turn that into a negative 47. So in this case, we would do 91 minus 47, and that would equal 91 take away 47 is 44. So in other words, going into week 4, she had the $44 during week 4, and so when she saved $47, it took her up to 91. Okay, so during week 3, she had this $44. Well, this is a negative 14, so we want to know what did she have going into week 3. So we're going to take this 14 and turn it into a positive. So now what we're going to do is we're going to take that 14 and we're going to add it to the 44 that she saved and added to the 47 that got her up to there. And if we do that, that'll tell us that when she entered week 3, she had $58. Well, she had $58 and she spent 14 and it took her to 47. Or I'm sorry, it took her down to 44 where she had 47. So now we know that going from week 2 to week 3 before spending, she had $58. Well, how did she get to the $58? Well, she added some amount. She added positive 26. So now we're going to take 26 and turn it into a negative. So now the inverse, of course, would be 58 minus 26, and that would give us a total of 32. So going into week 32, that tells us that the first week she saved $32. So basically, this is what we have. On the first week, she saved $32. Then she had another $26. Okay? And then she subtracted 14 from that. Then she added 47 to what she had, and she got up at 91. All right? So that's how you could have solved this problem and how much she saved during week 1. You may have set it up differently. Hopefully you now know how to problem solve using integers.